we have only 25 minutes to cover, the topic on how you can turbocharge your SQL queries with the help of Apache Ignite. And so today I just want to split the whole time into two sections. First, I will give you just a theoretical introduction, just a very general overview on the SQL capabilities of Apache Ignite. And then I prepared a special demo so that you can see how it works in practice, in real life, and at least you will be able to memorize something at the end of our conversation today. But before I start, my name is Denis Magda, and presently I take a role of a product manager at GridGain Systems, and at the same time I'm Apache Ignite PMC chair. However, my journey started as a software engineer in GridGain, and also I came to Apache Ignite as a contributor, but still I'm pretty technically qualified person, so you can ask a variety of technical details and stuff regarding the product. And I'm still kind of one of the most active contributors to Apache Ignite, so I can't live without coding from time to time, at least on where I have a spare time for that. So what's about Apache Ignite and how it's related to Percona conference in general, why we decided to come here and to propose you us as one of the solutions for the performance optimizations. So basically, Apache Ignite is more than a distributed storage. It's more than a computational engine. In a nutshell, it's an in-memory data fabric, which is a combination of perfectly integrated components such as a data grid, such as a clustering, compute grid, and SQL grid. So basically, how it's shown in this picture, you slide Apache Ignite. You can slide Apache Ignite in between your persistent storage, like MySQL, and your existing application, and having your data distributed across a cluster of machines. You can get significant performance improvements just because the data is stored on multiple machines of the cluster closer to your CPUs. That's it. So the idea is simple. Usually you start with Ignite by doing two things. The first one is that you just need to dedicate a special cloud environment or your own hardware for your cluster machines. And once all your nodes are interconnected with each other, once you have your cluster, the second step would be just to store your data there. And after you have the data, you are free to leverage from it. So you start executing your queries, you start updating it, you execute computations, and so on and so forth. When you need, and most likely you will need to persist your data, right? So we want to cover the situations when, by some reason, the whole cluster goes down. Probably the electricity can be shut down in your data center, and you don't want to lose your data, right? So, and once your cluster is up and ready, we want to preload the data from a persistent storage. And here is where you can leverage from both MySQL, and Apache Ignite. So the data will be persisted in MySQL database, and at the same time, it will be located in memory across a cluster of your machines. When the data will be updated in memory, all the updates will be automatically propagated to your disk layer, to your MySQL database. At the same time, if a value is missing in memory, it will be preloaded from your database. So the idea is simple. However, we tend to use SQL queries in production, right? So we are folks who are accustomed to work with relational logic. But Apache Ignite internally is a distributed key value storage. However, it doesn't prevent to use it for relational database use cases, simply because it supports its own SQL component, which we call in-memory SQL grid. It's a 1999 compliant distributed SQL engine that supports every operator, every statement that is listed in that specification, which means that once you preloaded all your data in memory, once you have it in your cluster, you can simply, switch your applications to this clustering solution, and most likely you will not be required to change your code at all, because if your SQL query is satisfied to this specification. So we do support aggregations, we do support joins, we do support distributed joins. For instance, if your data that is needed to for your specific SQL query is located on different machines and in different caches. So in Apache Ignite, we use a notion as a cache notion at the same level, at the same way as we use tables for relational databases. And so we can join the data located in different caches. As for the API, right? So you can execute the SQL queries using Java library developed for Apache Ignite, or .NET or C++ counterparts. At the same time, if you are accustomed to use JDBC or ODBC drivers, you just can use our own implementation of those drivers right away. So for instance, if you have, let's say, Python application or Ruby application that goes to MySQL database or ODBC driver, then you just can switch this application into the Apache Ignite cluster. That's it, using our ODBC driver implementation. One of the biggest challenge for distributed SQL engines is to guarantee a fault tolerance and result set consistency, even at the times when your cluster isn't stable. Let's say when you are joining new cluster nodes into your whole cluster, or some of the cluster members go down. But we made hard to make sure that you will get a result set for a specific SQL query consistent and complete all the times, regardless of the state of your cluster. Even if the time your query is being executed and some of the nodes went down, you still will get a complete result set. Because we know that in the conditions that you enabled so-called backup copies of your data. So because the data is stored, we do support the concept of sharding or partitioning. There are different terms for this. So and there will be kind of a primary node for your data, and there should be some of the backup nodes for your data that store some subsets. And if some of the node goes down, most likely that there are the other nodes that stored the same data sets before, and they will be able to reissue a SQL query automatically for you. So this picture depicts how actually a standard SQL query is executed by our SQL grid. So here is we have, let's say, this is our application that is connected over, JDBC, ODBC, Java, or .NET API. And then it issues some of the queries. And the query will go to every cluster node that potentially stores a data set needed for the query execution. And this mode is called collocated mode. This mode assumes that all the data, let's say that if you plan to join the data, like you have organizations and employees, then we expect that employees from all that work for a specific organization reside on a single node. And this thing can be easily achieved in distributed systems by harnessing so-called affinity collocation of data. So it's just for instance, here is when you will be, with this example, when you will be putting some employee into the cluster, you will link it with his own organization. And having such a reference, we will place employee, let's say from Apple Corporation, on the node where the record of Apple Corporation is located. And this gives us an ability to execute distributed SQL queries with joins in this collocated mode. And as you see, when the query arrives to every node, it's just executed right away, and you get back your result set. But at the same time, we do know that it's not feasible to collocate all the data. You might have just extremely complex queries with multiple joins. And for this scenario, you can enable so-called non-collocated joins, and the execution flow will look like this way. So the difference here is that when the query will be executed on every individual node, and at the time we need to join some of the data sets, if a node sees that some of the data is missing locally, it might go to the rest of the cluster nodes asking for the missing part so that it can join, so that it can prepare its part of the result set and send it back to your application. And we do suggest to enable this mode only if you couldn't come up with affinity collocation for the data, because the first way, this logic is much simpler, and we just need to rely on your configuration, making sure that the data is collocated. And in this scenario, you will get significantly fast execution of your SQL queries. But this approach allows you to execute, let's say, 100% of all your queries you have. They will work slower, but in any case, you will be able to complete them as well. Okay, that was about how we can read the data from our cluster. What's about data modification? So as for the data modification, since Apache Ignite is a kind of distributed key value storage, you can update the data using conventional key value operations like put key and value, put or get key and value. But at the same time, our SQL component makes it possible to use well-known DML statements like inserts, updates, deletes, and so on and so forth. So again, it's a kind of big plus if you, let's say, accustomed to use ODBC or JDBC, and you already have your application written, and the application relies on all of these statements. You can just give a try to our distributed system and switch your application to Apache Ignite. Okay. What's about management? So it's good, it's always good to write the code on our own, but at the same time, sometimes we need to debug our SQL queries. And for this purpose, I can offer you a couple of different tools. Apache Ignite has its own tool called Apache Ignite Web Console. So actually, it's a management and monitoring wizard and configuration wizard. So from the SQL perspective, what you can do, the first thing is that if you have your database, and for instance, you want to stick MySQL with Apache Ignite cluster, then the first thing you can do with Web Console is to connect to your database, import schema and the other configuration parameters from them, and all this stuff will be turned into Apache Ignite configuration, so that after that you can start your cluster with some ready-to-be-used configuration. And after that, you can connect to your cluster once it's up and running, and for instance, you can monitor the state of the cluster or execute SQL queries like it's shown on this picture to the right. Plus, if you know Apache Zeppelin or you somehow use it in production, you also can, connect from Zeppelin using a JDBC driver. Or if you somehow use Tableau for advanced analytical purposes, you just can put our ODBC, you just can rely on our ODBC driver and open up connection between Tableau and your Apache Ignite cluster. So that was a kind of a theoretical part of our conversation. So now let me quickly show you one of the demos I prepared for this talk. So first, here is I have MySQL database running on my local laptop. Let me mark it. So this database just consists of this one of the sample databases. I downloaded it from some MySQL resources. And here I just have tables for employees, organizations, salaries, and so on and so forth. What I want to do, so actually what I already did, I want to connect to this database. I want to import schema from it and turn the schema into the Apache Ignite configuration with all the indexes defined. And after that, also I want to make sure that my database and Apache Ignite are interconnected in the sense that when an update will happen at the level of Apache Ignite will update MySQL automatically so that the data is persisted there. So I will use Apache Ignite Web Console. This instance of Apache Ignite Web Console is hosted on GridGain site. So this is why you can see GridGain logo. But in any case, nothing prevents you from taking Apache Ignite Web Console and deploying your own environment. Here I have configuration. I don't want to spend a lot of our time, but I will show that here is actually, I just defined configuration for my cluster. And this part is more interesting for us because here is, I can show how we can import schema from our database. So for instance, let's suppose that I removed all these things. I want to connect to my MySQL database. I need to run a special application called Ignite Web Agent that works between your web application, Apache Ignite web application, and your cluster. Now it's up and running. And using this application, I will open up a connection to the database and import scheme from there. So here is my local database, password and username. We are connecting to it. I want to import employee scheme only. These are all the tables we have over here. And for every table, we will create a respective Apache Ignite cache configuration with all the indexes defined. These are some advanced settings. We are not going to spend our time reviewing them. And finally, here it is. So the configuration is ready. There are some mappings for this scenario when you want to persist data as well. So don't. In reality, everything is much more simpler. So next at the same time, here is configuration for our caches. So the place where the data will be stored in Apache Ignite cluster. And finally, you can download a project with all the configuration and some so-called startup files that you can use to start your cluster with the prepared configuration. So I downloaded this project before. Here it is. And now let me show, this is one of the configurations that was created automatically by a web console for me. So the biggest part of this configuration is needed for this intermediate layer between Ignite and MySQL, because when we will be trying to update some data, we need to turn update into this respective statement of MySQL. And this is why we have some lengthy definition for all the caches, for all the tables we have. Now let's start one of our Ignite cluster node. So here is what I use. I just need to call this API method and pass configuration. Let me quickly increase the font size so that you can see what's going on. Okay. Okay, now we are waiting while our cluster node is being started. And now also I want to connect to the cluster from the monitoring from this web console side. I want to take a look at the state of my cluster. So right now we see that there is only a single node running in my local cluster. And these are the caches that are deployed. All these caches we created all these caches by importing data, by importing scheme from our database. Even more, now what we can do, we can connect to MySQL using this automatically created file. Not to MySQL. So actually, while this stuff is starting, here is what we are doing. We are connecting to the cluster, and we initiate caches preloading. So we will preload departments cache, employees cache, and manager cache. But you know what? So as soon as MySQL is connected to our cluster, when this method is triggered, an Apache Ignite layer, Apache Ignite will automatically go to our MySQL database and will preload the data from there.
Question. Can you limit somehow the amount of data you want to load? Or?
Actually, no. You can specify different filters. So if you want to filter out some data, you can do that. And here, as you can see, that the size of the caches of the data is being grown. I think that this amount is more than enough for you. So now I want to alter the preloading. And so we have some data sets here. This is the memory consumption, CPU consumption. And now let's go to queries. Here is I'm going to execute some of the queries over the data that I have in memory. Presently, this underscore key notion is used as a primary key. So because like every entry that we have in our cluster has a corresponding key, and presently we use this special keyword if you want to get a key value. But going forward, as soon as we support DDL, you will be able to, you will not be longer needed to use these special statements at all. And here is what we are doing. I want to get 10 records ordered by ID. So and here is, if you take a look, I have the same records in my MySQL database, like don't miss and like that. Now let's try to update, let's say, this first record using our simplest DML statement. So we just need to specify this key, which is our primary key. So we are done. Now let's check that the data was updated in memory. Okay, the last name has changed. And also, the data must have been updated in MySQL. It is. It was updated. And also you can, for instance, delete the data. So let's say what we have, let's delete this record with ID 06. Okay, we no longer have this data in memory in Apache Ignite. And what's about... And the same is true for MySQL. So this is what I plan to show to you. So, and you, let's say, as a relational database user, now you can see some of the benefits that you can take advantage of by combining your, let's say, existing relational database-based solution with Apache Ignite cluster, and then can significantly accelerate your SQL queries performance as well as other components. Yeah.
So how do you manage schema changes?
So you can. The point here is that if you try to update, so You can easily update schema using in Apache Ignite. Like you can define new, we call them fields. You can define new indexes. And in 2 weeks, we will release the next version of Apache Ignite. You will be able to use standard DDL statements like create index or alter index if you need to change something in memory. But that will be updated only in memory. So meaning that if you need to change the schema in MySQL, then the same has to be done for Apache Ignite.
So we will apply the schema change on the database, apply schema change.
And then you need to apply the same change at GridGain at Apache Ignite level.
Regenerate the cache just in the table, right?
So you don't need to regenerate your cache actually. So let's say that you decided to add new field, right? And you want to make it an index field. You can do this in runtime. You don't need to restart your cluster, and you don't need to stop your application. All this can be done while you expect all these operational workloads.
And you can do this by API calls, so it doesn't have to do with the user interface?
This will be available over DDL statements like create, update, alter index. Mm-hmm.
How does it work with like a cross-site replication? Like you have a master or a cluster here, a cluster here, right?
Uh-huh.
Cluster A, does it replicate?
So Apache Ignite doesn't have data center replication, but GridGain, which is built on top of Apache Ignite, it has data center replication feature as a part of its functionality. Okay, so if you have any other questions, you can catch me outside, and I will be happy to answer them. Thank you for coming here.